Okay, lecture 23. We want to solve these quadratic equations. So for A, we see 3x squared equals 21. So we divide by 3 on both sides. We get x squared equals to x squared equals 7. Then we square both sides. We square root. We square root both sides. We get x equals to plus and minus the square root of 7. And I have square root signs. Square root of 7. One with a positive value, one with a negative value. So I got a plus minus, I can write together as this. So the solution for A is a positive and negative square root of 7. Now let's see B. B, remember sum of 2 squared. Or we could do this. We move 25 to the other side. So get the 16x squared equals to negative 25. Right. Then we divide it by 16 on both sides. Divided by 16 on both sides, we get x squared equals to negative 25 over 16. Then now we square root both sides. When we square root both sides, we get x equals to plus minus 2 values, one positive, one negative, because negative square is also positive. Square root of 25, well, let's see square root of negative sign. Square root of negative sign is I, right? We can write I up front or behind the number. Square root of 25 is 5. Square root of 16 is 4. Okay. So basically what we did here is we square root both sides. We square root x squared. We square root of negative square root of 25 over 16. Well, square root of negative 1 is I. Square root of 25 is 5. Square root of, in the denominator, 16, that's 4. So second one will have different terms. We have 3 terms. Right. The first two is A is 3x squared equals 21. 16x squared equals negative 25. So we could solve this way. Or there's another way solving this actually. Let me write that too. Another way of solving this is we divide by 3 first. We get x squared equals to 7. Then we think about moving 7 to the left-hand side. Get x squared minus 7 equals 0. Then we can use difference of 2 squares. X plus square root of 7 times x minus square root of 7. Then by 0 property, we can split into 2, right? That means x plus square root of 7 equals 0. and x minus square root 7 equals 0. So we get 2, right? This one gives us negative square root of 7 as a solution. This one gives us positive square root of 7 as a solution. So either way, get a positive, negative square root of 7 as a solution for this one. For this one, similarly, we can think of difference of two sums, right? So we have x squared. We divide by 16 on both sides. We have x squared equals x, well, divide 16, so we get x squared plus 25 over 16. 25 over 16 equals to 0, right? Difference of two squares in real number is the sum of two squares in complex number. You can split, factor this as x plus 5 over 4 I squared, not square. Then multiply by x minus 5 over 4i. So difference of two squares in real number, then sum of two squares in complex number. So this also gives us two values, right? Plus minus 5 over 4 I, complex numbers. So either way, okay, I show you two ways. But now let's compare to second one. We are asked to do by completing squares. So let's see how do we completing square. We call it completing the square or completing squares. Right? So we're going to do this. We're going to rewrite the equation as this. We're moving 12 to the other side. Okay, first step. Then we think about the 10 divided by 2, which is 5. We rewrite it as plus 2 times, let me write this way, 2 times 5 x. Right. Remember perfect square, like a plus b squared equals to a squared plus, let me write it here actually. Perfect square formula, a plus b squared equals to a squared plus 2ab plus b squared. Okay. So that's why you see I have 2 here. That's why I factor out 2 here, because there's a 2 in the formula. Can I change the color? Then this equals to negative 12. So I need to make this square. You see, I have so x is a square, and b is 5, right? You see, in the formula, I have 2a. Here, I also have 2a. If I write x here instead of here, you see my 2a, my a is x, my 2a is 2x. Then 5 will be my b. So this is plus b squared, right? Plus b squared, what's b squared? 25. Then I plus on both sides. I need plus 25 on both sides of the equation. Now the left-hand side is a perfect square. It's x plus, use this equation, x plus 5 squared equals to the right-hand side of -12 plus 25, which is 13. Now I can square root both sides. Right? So I square root this side. I square root the right-hand side. But when I square root, I get a positive value and negative value because a negative number square also positive. So in that case, so now I get x plus 5 square root cancel each other. I get a plus minus or plus or minus is better. Square root of 13. Now I just move positive 5 to the other side, right? Positive this side. When I move to the other side, it becomes negative 5. By convention, we like to write the real part. By convention, we like to write the rational part first, the irrational part second. Okay, so that's 8. Let me move B. So B is very similar. B is similar. The only difference is there's a 2 in front of x squared. So what I'm going to do is I'm going to divide everything by 2. Divide everything by 2. I get, because I have an equation, I can always do this, right? I have an equation to work with. I can divide, I can add, I can subtract, I multiply the same number on both sides simultaneously. 6 divided by 2, I get 3x. Then minus 5 over 2. It's a little bit annoying, right? Because I have to deal with this. But you know what? I'm going to change this number to be easier. I'm going to change it to be 4. Okay, let's change this one. Just to, not to calculate so much. But this one, if you see it, this one is factorable, right? So let's factor first. So this one can be factored as x minus 4 times x plus 1 equals to 0. Then we get x equals to 4 and negative 1. 2 solutions. But we need to completing squares. So let's do that. Let's completing squares. So we divide by, like, oh, hold on a second. I need to change this one to be 8. Right? I need to change that one to be 8 in order to get this. So I change the numbers a little bit different, so we don't have to get too much into fractions. But still, we need to get into fractions for completing squares. Because we're thinking 3 divided by 2, right? Because we're thinking we want to rewrite this as x squared minus 2 times a is x. And then do we see 3 over 2? This is a little bit tricky to see it. It comes from taking the 3 divided by 2. Okay, then just add 3 over 2 squared, which is 9 over 4. Right. I do this on the left-hand side. I have to do this. Oh, you know what? Let's do this way too. Then if I add 9 over 4, I'm going to subtract 9 over 4 as well, if I do on the same side. then minus 4. That equals 0. So now you see I have a perfect square form because this 9 over 4 is just 3 squared divided by 2 squared. I'm going to write it in a square form. Right? It's the same as 9 over 4. But now this first 3 terms gives me a perfect square, which is x minus, oops, I need a equation formula. X minus 3 over 2. I think the annoying part is to think about, oh, you know why we need to do that's the process of completing squares. Okay. Then I'm going to move 9 over 4, negative 9 over 4, and negative 4 to the other side. Right? That becomes 4 plus 9 over 4. How do I do 4 plus 9 over 4? 4 is 16 divided by 4, right? So I can rewrite 4 as 16 divided by 4. And 16 divided by 4 plus 9 divided by 4, I get 25 divided by 4. And 25. Now what do? Now I square both sides, square root both sides. Right? I square root, I have perfect squares now. I square root. I perform opposite operation. And when I square root, I always do plus minus 2 values. So now what do I get? I can back, okay, yes, I can. Now x minus 3 over 2 equals to plus minus 2 values. And now we know square root of 25, which is 5. Now we know square root of 4, which is 2. Right? So now I get x minus 3 over 2 equals to plus minus 5 over 2. So I move negative 3 over 2 to the other side. I get 3 over 2 plus minus 5 over 2. Well, when it's plus, 3 plus 5 is 8. 8 divided by 2, that's 4. So I get 2 values. I get a 4. Then 3 minus 5, that's negative 2. Divided by 2, that's negative 1. Indeed, I have the same solution as this, right? When I factor, I get a 4, negative 1. When I do completing squares, I also get a 4, negative 1. So that's it. That is to say our answer is right. Okay, let's see number 3. Number 3, she wants us to use a quadratic formula. Remember quadratic formula? Let me remind everyone. Let me just write the formula. So x value, oops. I need my equation. X equals to a fraction. The numerator is negative b plus or minus 2 values square root of b squared minus 4ac. The denominator is 2a. So first we need to identify ABC from the equation. Can I move this up? No. So from the equation we see to identify A. Remember A is a number before x squared, which is just 1. So let's do this baby step. B is the number before X, which is -6. And C is a constant, 3. Okay. So once we have this, we just plug into the formula. Plug in the formula. Well, negative B is -6. -6 becomes just 6. B squared, -6 squared, just 36. Minus 4 times A is 1. Anything times 1, let's not bother to write it. Then times 3. 4 times 3, 12. 36 minus 12, that's 24. 24 can be simplified as 4 times 6, right? 4 times 6. Square root of 4 is 2. Square root of 6, we just keep it. Right? Cannot be simplified. The 2 square root of 6. A is 1, so we just get 2 in the denominator. Now we can split into 2. We split into, I'm going to change those numbers, okay? Copy paste is easy. I get 6 divided by 2 plus or minus 2 radical 6 divided by 2. Okay. I see this can be simplified. 6 divided by 2, that's a 3. 2 radical 6 divided by 2, this is radical 6. Right? It's just radical 6. And that's it. That's the solution for this one. 2 irrational solutions. So we get a 2. Because this file, I use Google Doc to translate it. Translate the PDF file to a Google Doc. So that's why it's weird. But it works, right? So we have 2 irrational solutions. 3 plus radical 6 and 3 minus radical 6. Let's see 4. 4 we also have 2. What do we want to do with this? We just have 1. Or 3 we just have 1. First thing, find the discriminant. Who is the discriminant? In the square root, right? In the quadratic formula, I'm going to rewrite it. Remember, in the quadratic formula, we have a square root of b squared minus 4ac. Right? So the b squared minus 4ac is called the discriminant. Okay. So this b squared minus 4ac is called discriminant. It could be 0, it could be positive, or it could be negative. Right? So let's see through these 3 situations. So the discriminant is, I'm going to put the discriminant before this. B squared minus 4ac. Right? It could be 0. If it's 0, what happens in the formula? Let me rewrite the formula one more time. I have negative b plus minus square root of b squared minus 4ac, then divided by 2a. If when x equals 0, let me put this somewhere else. Before this. Quadratic formula. So the discriminant is the b squared minus 4ac. If it's 0, what happens? Square root of 0 will be 0. So this is gone, becomes 0. So get an x equals to negative b over 2a. Only one solution. Okay. Now let's go back to the equation. Let's go back to this equation. I'm going to move this one down somewhere here. We see this one can be factored because our solution, this is in only one rational solution. Only one rational solution. If it's even one or two rational solutions, that means the original equation can be factored. So you see, indeed, do you see how we factor this one? This can be factored as 3x minus 1 squared. Equals to 0. Right? 9x squared is 3x squared. Then that means 3x equals to 1, or 3 minus 1 equals 0. That means x equals to 1 over 3. Only one solution. Right? If we do here too, negative and negative b, negative, negative b, because b is negative 6, so it just become positive. Become positive 6. Then denominator 2 times 1, just 2. 6 divided by 2, that's just 3. No, something's wrong. Oh, a is now 1. A is 9. Do we see a is 9? A is 2 times 9. 2 times 9 is 18. 6 divided by 18, indeed. 1 over 3. So A is a perfect square. That's why I only have one solution. We can also go through the radical quadratic formula to see is the same solution, one solution, which is 1/3. Now let's see this one. Remember, we want the completing squares, right? Oh no, this one is discriminant. Again, let's use this. So we want to find b squared minus 4ac. B squared minus 4ac, in this case, let's figure out ABC first. A equals to 5. A is the number before x squared. B is number before x is negative 4. Now C, we have to be very careful. C, we have to move negative 6 to the left-hand side. It becomes positive 6. Right? So C is positive 6. So b squared minus 4ac, we get b squared, which is negative 4 squared, which is 16, minus 4, times a, which is 5, times c, which is 6. 4 times 5, 20. 20 times 6, 120. 120, negative 16 minus 120, we can think as negative 120, negative outside, 120 minus 16. Right? We still have negative 120, positive 16. 120 minus 16 is 104. Right? 104 can be simplified. Equals to negative 4 times 26. Okay. So the discriminant is less than 0, is negative. I'm going to use this again. Quadratic formula, copy and paste down here. Yes, I have to make a turn over here. Okay. So negative 4, that's positive 4. Plus minus the discriminant that we already calculated, which is negative, is negative 4 times 26. And the 2 times 8 is 5. 2 times 5, get 10. Well, this we get, oops. I get a 4 divided by 10. So I'm going to copy paste and change, okay? Just typing in here. Right. So I get a 4. Then I got a plus or minus. I'm just writing, split those two numerators. Right. Right. Let's look at this one. So the rational part is 4 divided by 10, which can be simplified as 2 over 5. This negative irrational or complex imaginary part, right? Because square root of -1 is I. I'm going to write I up front. Square root of 1. Square root of 4 is 2. So I'm going to write 2 out. Then the radical left with 26. 26 is 2 times 13. I cannot simplify anymore. So that's it. That's my answer for B. I got 2 complex roots. The rational part, the real part is 2 over 5. The imaginary part is this. Oh, this can be simplified. I have 2 over 10. So this simplified to be square root of 26 over 5. Okay. Now let's see 5. 5 is saying write an equation with a given solution set. So let me split those two. Next way I could do this. So I have 2 questions here. The first question is saying x equals to, I don't need capital 1, I don't need capital letter. Okay, I'm going to use the equations. X equals to 3 and x equals to -2. Right? Where does this 2 solution come from? We're basically doing backwards. X minus 3 equals to 0. And x plus 2 plus minus -2 become plus 2 equals 0. Right. Then 0 times 0 is 0. So I can multiply those two. X minus 3 is 0. X plus 2 is 0. So their product is still 0. Then I FOIL it. Right? I FOIL it, or I smile. I get x times x, x squared. And -3 times +2, I get -6. Right? Equals 0, but then I have middle term. Middle term comes from -3 times x plus x times 2x. So -3x plus 2x, that's just -x. So this is the solution for 8, for 5, 8. Because she wants us to write an equation for the given solution. So we go backwards. Because when we solve a equation, we go through the equation, we factor, we use the 0 property, then we get the answer. So this one is backwards. We are given the solution, we write with x equals 3, x equals -2. Then that means x minus 3 is 0, x plus 2 is 0. 0 times 0 is 0. We multiply these two. Then we expand, right? So get x squared minus x minus 6 equals 0. Similarly, for b, I'm going to copy this, just change the numbers. So now I have 5i and negative 5i. Negative 5i. I'm going to do the same thing. X minus 5i equals 0. X plus 5i equals 0. 0 times 0 is 0. So x minus 5i. And x times x plus 5i. Still 0. Then I multiply out. So I get x squared plus 25. You see, negative 5 times 5, negative 25. I times I is I squared. I squared is negative 1. Negative 1 times negative 25, that's a positive 25. What happens with the middle term? The middle term, I have negative 5ix and positive 5ix. They cancel each other. So my equation is x squared plus 25 equals 0. Okay, these have two solutions. This does not have solutions in real number system, but it does have complex solutions. Okay, I'm gonna make another video for the graphing. All right, so this one. So this covers 5 questions for lecture notes 23.